Hello everyone, welcome back to my channel. So in the last video, we discussed regarding the three traversals in binary tree, that is pre-order, in-order and post-order. And in this video, we will discuss regarding the level-order traversal, which is slightly different but important as well. So likewise, the name says level order, that is we will traverse level by level. So before starting, let me first segregate all the nodes level wise. So this is level 0, then level 1, level 3, level 2 sorry, level 3 and level 4. This tree has maximum level 4, 0, 1, 2, 3 and 4. Okay, so what this level order traversal means, that is if I want to give the output of this traversal, it would have been first print all the nodes. This traversal means that print all the nodes first of zero level, then of the first level, then of the second, then third and so on, and of a particular level the order sequence should be from left to right. Let me tell you. First I'll start from level 0. I'll print A. Okay, I printed A over here. Then for level 1 I'll start from left, that is B and C. So I'll print B, then I will print C over here. Yes. Then next level, that is level 2, we have D, E, F, and the order of printing should be from left to right, that is D, then E, then F. So I will print D, then E and then F. Similarly for the third level, G, H, I, J, K, and the sequence should be from left to right, that is G, H, I, J, K. So I'll print G, H, I, J and then K. Okay. Now for the last level, the sequence should be from left to right, L, M, N, O, P. It is, I'll print L, M, O, P, sorry, L, M, O and P. So that should be the answer. To achieve this answer, now the question comes, what data structure should I use? The recursion would simply not lead to give us this answer. Instead, we use a data structure called queue. We use a data structure called queue over here. If you do not know what queue is, it is simply just like the name says, it first in last out. That is, for example, when you go for like buy any ticket for a movie, you can see the person standing on first, then second, and similarly there is a queue. Okay, so the person who came first will go out. So it is first in first out, FIFO. Sorry if I told you first in last out, sorry, I recorrect that. It is first in first out, that is the person who came first will take the ticket first and leave this queue. Similarly for the second person who came second will take this ticket second and leave. Okay, so similarly for a level, let us take example of second order. Okay, second level, that is D, E, F. So if I print, if I store D, E, F, and if I'll pop out D, then E, then F, so I can say that if I'll store from left to right, I'll be able to print them in the same order. So this data structure would help us give us the exact answer. So before jumping on to the code, I'll take one more example of a tree. Okay, so a short example before jumping on to the code part. 1, 2, 3, 4, 5, 6, 7, 8, then 9. So before starting, as I told, we'll segregate them level wise, because dry run is very much important to understand any concept of DSA. Okay, so as I told, the traversal starts from the root, that is 1. So I'll print 1, Then for this this level, I'll store all the elements, the left and then right of this one node. I'll store in a queue 2 3, then moving then I'll print again. Then for next level, when I'll move to the next level, here I'll pop out the first one, that is I'll print 2. Okay, I'll check what are the left and right. I'll store this also in a queue. We have 3. Okay, I'll store the left and right of 2. Okay, 4 and 5 of 2. Okay, then this is done. And for the last level, 3 was a node from the previous level. Okay, so I'll pop out 3. I'll print 3 over here and store the left and right of 3, that is 6 and 7 in a queue. Okay, now these are all nodes of this level, right? Now moving on to the next level. First I'll pop out 4 over here from here. What are remaining? 5, 6 and 7, right? I'll store left and right of 4 in this queue, that is 8 and 9, right? Since I popped out 4, I'll also print 4 over here. 5 was a node of the previous level, so I'll pop out and print and check whether it has left and right. No, it does not have left and right, so leave it. Similarly for 6, I'll pop out and print. It does not have left and right, so I'll skip. For 7, I'll pop out and print, okay, and check whether it has left or right. No, it does not have, so skip it. Now moving on to this last level, I'll pop out 8 and print. Does it has left or right? No, it does not, skip it. And for 9, I'll pop out 9 and print it. It does not have left and right, so I'll skip it. So this is the level order traversal after using queue. Okay, so now we'll proceed with writing the code. You might feel a bit difficulty in understanding the code, but if you have clearly understand what I have told previously in this video, I have did the dry run using queue data structure for level order. You'll definitely understand. If not, you can revisit that part again and then come up over here. Okay, we'll proceed. Before starting, we'll make a queue. Okay, queue of what type? Of node type, because all the nodes are of node type in the tree. I'll name it and new linked list. Okay, so this is how we create queue in Java. Okay, now what more? I'll add. Okay, for adding we have functions dot offer, and for popping out we have dot pull in Java. Okay, we'll offer what? We'll push the root into this queue dot offer root. Okay, now till when we will execute? Okay, till when we will be executing? Till the queue does not get empty. So in the while loop, I'll write the condition while queue is not empty. Till we have elements in this queue, we'll execute. Okay, and now what next? I'll store the size. Int n equals to queue dot size. Why size? Because this variable n size will help me know that how many elements was there in the previous level. For this, the n would be 1. For this, the n would be 2. So this n would let me know that how many elements you have to pop out of the queue. Okay, because the popped out elements are of the previous level. I hope you understand this. Okay, now we'll run a for loop for what? Popping out the nodes of the previous level. For int I equals to 0, and I will run till n, which is the queue dot size. And the size, I'll repeat, the size means the number of nodes of the previous level which are there still in the queue. Okay, I'll do node queue dot poll. Okay, I popped out. This is the function to popping out of the queue. I popped out, and I know that this particular node is of the previous level, so I'll print it. System dot out dot print node dot val with some empty space. Okay, now check what does it have left element. If node dot left is not equals to null, that means there is a left node. Then do queue dot offer, that is add this left of node inside the queue. Okay, I did it. Now again check does it has a right. I'll do node dot right. If node dot right is not equals to null, that means there is a right node. Again add that, that means queue dot offer node dot right inside that queue. Okay, done. So I did this. I popped out the element. Which element? The element at the previous level. Then I printed it and I checked does it has a left, does it has a right. If yes, then add that. Okay, left and right. If there is a left and right, add that. Now we'll end this for loop. Okay, end this while loop. Simply done. So this was the code. You can again watch the dry run part and then come up to this part. This is a very easy code using queue data structure, where I stored all the elements into the queue and popped out only the elements which were there in which used to belong to the previous level, and which node used to belong to the previous level. How I got to know? Using this queue dot size. I hope you understand well. If any doubts, drop it in the comment box. Thank you.